Hi,
So,
Roy. Thank you so much for joining our podcast. Pleasure to have you. Thanks for taking out time on a very short notice. Just for our audience, please introduce yourself.
sure. Thanks for having me. My name is Roy Hasson. I'm the VP of Product and Marketing in a company called Upsolver. We primarily focus on high volume data ingestion and maintenance for lake houses using Apache Iceberg. I came from AWS before Upsolver. I was a product manager and go-to-market specialist for many of the AWS analytics services, and just been around the industry for quite some time now.
Hmm. Awesome, awesome. So it's good that your core is working on Iceberg, and this Iceberg is something which is getting very famous nowadays. My
Awesome.
quick background is I am a solution architect in data field for last 20 years. So I'm very much interested in all these kind of technologies, which is surfacing here and there. In my book, I am Datapedia. I have around 300 plus topics. So my idea is to touch base each technology in a very precise and you know for a perspective, and which
Yeah,
gives me an added advantage in my working life as well. So this podcast is my personal initiative, but which very much complement with my professional life as well. So it's a
very good.
win-win for
Cool.
me. Yeah,
Awesome. Good to hear that.
yeah. Thanks. So we have been working on Delta Lake and lake houses from database concept, and suddenly this iceberg comes in. So tell us a little bit background of iceberg, when it started, when it came to being. Then I will go into technicalities and let's
Sure.
understand what iceberg is. Yeah.
Sure, yeah. I mean, there are lots of content out there, blogs and
Hmm.
posts that you can read about kind of the history. But in very short, some folks at Netflix created Iceberg as a way to manage their very, very large data lakes, primarily on AWS, but they were looking for a way to kind of deal with large data sets, updating these data sets, deleting data from these data sets without having to, recreate tables, move a lot of data around, something that was traditionally more, needed to do in Hive tables. Apple kind of jumped into the mix as well. They had similar challenges that Netflix had with their platform, and they kind of birthed the Iceberg table format. I think along the same timelines, Hudi came out of Uber for solving similar challenges, incremental updates of very large databases, and then Databricks with Delta Lake around the same time started to come up with Delta Lake for a similar purpose as well, but mostly for their customers, not for their own internal use. Um, and then I think over the last year, Iceberg really took off as more and more companies started to adopt it. So Snowflake picked it up and started using it as kind of their primary open table format for storing data outside of Snowflake. AWS, of course, picked it up. Google did. Microsoft with Fabric initially started with Delta, but then provided support to go into Iceberg as well and are slowly adding native Iceberg support. One that was really exciting to me is Salesforce that came out and said that they're going to support Iceberg as well in their data product. So that's really cool. That's kind of where a lot of the excitement over the last year or so centered around Iceberg, and I'm sure we'll get into some of the technical details as well.
Yeah, so in nutshell, what we are saying is it's in a not a competition, I would say. It's something similar like delta tables, is it? Because the major takeaway for delta tables is for ACID capability, which was not there in Spark, right? And that is where
So
delta majorly
yeah.
came in. Yeah.
Yeah, so I would say that there are probably two primary reasons why these table formats started. And again, depending who you ask, you may get a different perspective on this. But Hudi and Delta Lake came to be while I was still at AWS, working with customers to build data lakes. The biggest challenge that we face with data lakes is not necessarily the ACID properties of these tables, but the ability to update data in place in S3, and of course in a consistent and reliable way, but the
Mm,
updating of data was really problematic in S3. Right. To update any data, you have to kind of download the Parquet file, replace the row, and then delete the old Parquet file and upload the new one. And that was
mhm,
just manual work that you had to do in existing Hive tables. So Hudi, Iceberg, Delta all provide mechanisms to basically automate that process. So that was number one, right? Being able to update and delete data in object store with a lot of hoopla and extra work.
mm,
And then the second one is around optimizations, like be
mm.
able to do compaction, be able to do cleanup, something that was highly needed in order to get good performance when it comes to querying the data using Presto and Trino and Spark and tools like that. But there was really no way to do it in a simple manner, right? It required you to write custom Spark scripts and run them and troubleshoot them. I've built many of those to be able to compact and optimize data so users can query them efficiently. And it was simply just unmanageable. And once users are starting to put more data into data lakes, very quickly they realize that managing these data lakes optimizations and updating data in the lake was just hard, right? And that was the feedback that Databricks, for the most part, got from their users, and one of the reasons why they built Delta Lake. And then in parallel to that, Uber and Netflix were feeling the same pain within their own little bubble, right? And developed these, Iceberg and Hudi as tools to fix that. And then Snowflake kind of came out and said like, oh, warehouses are great. We're going to do everything in the warehouse. Everybody shifted to the warehouses. And then fast forward a few years into 2024, and now we're realizing, hey, this is actually not the most cost-effective way to do this. We can do it better. And we have these open table formats now that have matured over the last few years to a point where any user can actually go and use them. So that kind of swings the pendulum back to the data lake world to say, let's get those benefits of a data lake now that we have these open formats to address updating and deleting, compaction. And on top of that, you get asset transactions, you get better partition evolution and schema evolution. So you get a bunch of extra benefits on top of that.
Yeah, so the third file format you just mentioned, Hudi, right? So
Yep,
that
that's
is
right.
also let's bring this piece as well into it. The optimization and partitioning which you is mentioning, right? That is there in Snowflake as well. So when Snowflake do it, do they use Iceberg at backend or how, or they have their own file format? Because they don't use Delta,
So,
right?
so No, so Snowflake has you can think of it as two types of persistent layers, right? Everything is stored in S3 at Snowflake. There are two ways to store the data. One of them is proprietary file format. You can think of it as like a fancy Parquet file. Under the hood, they store the data in these file formats. They optimize it in ways that only they know how.
Hmm.
But then all the partitioning and the clustering and the rearranging of the data, all of that happens inside of the warehouse, right? Inside of
Yeah,
Snowflake,
correct.
not necessarily on the object store. On
Hmm.
the other side of it, now they have support for Iceberg. And with Iceberg, um, they're going to store the data in Parquet format. So that's an open file format rather than the proprietary format that they have for their native stuff. And then in addition to that, all the metadata, right? Statistics, schema information, partition information, all of that is stored in the Iceberg table format, right? These are manifest
Hmm.
files. I think of them as text files with, a bunch of information.
Hmm.
Um, right? Instead of storing that inside of the Snowflake catalog within their box, now they're stored on the object store, right on Amazon S3, for example, as files that any engine can pick up and start using, right? So
Hmm.
the metadata and the physical data are completely open and available to any engine to use, right? So
Okay.
Snowflake kind of offers you both of those modes.
Yeah, so I think same, let's jump onto Databricks as well. So Databricks is also offering
Yep,
Iceberg and they have Delta tables over there, right? And within Delta tables, the backend of Delta is Parquet as well. And they
that's
can
right.
create external tables on top of the Parquet, right? So yeah, you are right. Once you load into a managed tables of Delta tables, backend it's a Parquet, but you can external compute cannot read those Parquet directly, which has been written on top of Delta tables. But is that different in Iceberg?
So, a couple of things to kind of
Mm,
explain here. I'll take a quick step back on the
mm,
Databricks part of it, and then I'll answer the querying the files themselves. So, Databricks, in essence, very similar to everything else from an engine perspective, but they've chosen or they built the Delta Lake format,
yeah,
right? That's sort of like you can think of that as their Snowflake native
yeah,
format, right? That's
yeah.
their kind of format. Now, it is open source, it is available, so it's not completely closed.
Mm, mm,
However, they're using it within their platform as this native format. So when we're talking about Iceberg from a Databricks perspective, they're talking about Iceberg as an interoperable format. What that means is that users will interact and work with the Delta format. So when you create a table, when you write and update and delete from a table, all of that is happening on the Delta file format.
yeah.
You can then flick a switch and say, I want that table to also be exported as an Iceberg table. So what it does is it sort of takes your a snapshot of your Delta table, creates manifest files that are representing the Iceberg file format, sorry, table format. So then you can query that table from an Iceberg engine. But all you get is a read-only view of your Delta table in Iceberg format. So when we say Databricks supports Iceberg, they don't quite support Iceberg like Spark does or Snowflake or
Mhm.
Redshift. They support Iceberg as a read-only view of a Delta table. So if you wanted to update the Iceberg table, you can't actually update the Iceberg table. You have to go to the original Delta table and update it,
Ah,
right?
okay.
And once
Okay.
you do that, then new manifest files get generated, and then you can query that data from an Iceberg engine like Snowflake, for example,
Ah,
right?
okay. So,
So that's how Databricks sort of today implements Iceberg. Now, I hope that they're going to change it and become full Iceberg compliant in the future, but currently that's not the case, right? And this is all done through Unity Catalog and this
yeah, yeah.
uniform, tool that they have that converts formats. But to your question about the Parquet files themselves, the Parquet files are accessible. Like they're in your bucket, in your S3 bucket or your object store. You can get them, you can query them. The challenge that you're going to have is that the way Delta and the way Iceberg store this information is that basically as you update and delete and insert new rows, new files gets created, right?
Okay.
So if you simply go to the Parquet files and query all the Parquet files, you're going to end up with a lot of duplicates, right?
Yes.
Because it's kind of like repeating itself, like a new row gets added, another one was deleted, but we didn't actually physically remove the row. We just
Yeah.
told you ignore this row. And that information is captured in the transaction log for Delta or the manifest files for Iceberg. At query time, those things get resolved, right? And then
Yeah.
you get the most recent data. Now, over time, you'll be compacting these files, right? You'll be creating, kind of joining a bunch of the little files into bigger files that give you
Hmm.
performance benefits, but it also materializes these changes. So if there's a deleted row and you just marked it as delete, now it's physically being deleted as the files get merged together, right? So
Yes.
ultimately, if you query the history, you should get some consistent view of the data without duplicates. But if you're querying the more recent, span of time, typically like an hour or so, depending on how fast you're compacting and merging,
Hmm.
you'll get duplicates, right? And you'll have to
Yeah.
kind of deal with it.
Yeah. So I think we are on the same page. Thanks for highlighting upfront, right? When you write on top of Delta table or on top of Iceberg, although it stores into the Parquet, into the object storage, and although someone else can directly hit those Parquet files, but it'll be much difficult for them. It will not be as seamless for them. Someone third party, when they hit these five Parquet files, they have to write a lot of things. Find the latest record was being deleted. A lot of those things has to be written. If mini
Yeah.
partition and all those things has been done directly from the front piece, which is I don't think Delta can do. I think Iceberg can do, just like Snowflake. If Iceberg is doing partitioning at back end, and if third party comes and hit those bucket, they have to find out and need to know what's being done, right? So it's not directly, you know, directly just select static and you will find the exact things. You won't, right?
No, in either so Iceberg and Delta work in a very similar way.
Yeah.
Just the way they write the metadata is a little bit different, but for the
Yes.
most part, they operate very similar, right? They're really not that different. Again, I would completely discourage around querying or accessing the data directly.
Directly.
So
Yeah.
you can think of Delta and Iceberg and like all these table formats as kind of like a map, right?
Hmm.
You don't know where stuff is, you don't know what file has what row,
Yeah.
but if you ask the map, right, if you have the table format, the manifest files, it'll tell you which files to grab, right?
Okay.
So like, yes, you can go and query those files directly, but you
It's
should
not
never do that.
recommended. Yeah. Okay.
No,
This
no, no, no.
I think this discussion is going very good. Thanks for accepting my invite. Now let's go to
Of
the
course.
next level, right? So now Delta has Databricks, which has their own compute. What about Iceberg? Iceberg comes their own compute, or any compute can use this Iceberg? How?
Yeah, that's a good question. I think that's something that a lot of people tend to kind of get mixed up. So Iceberg is just a standard, right? It's a specification that tells you how to encode information about changes to data, right?
Hmm.
So it includes a bunch of code like SDK and libraries just to make it easier for engines to interact with that table format. So you don't have to write that stuff from scratch. Right. So
Hmm.
Spark has the SDK, like Absolver. When we started using Iceberg, we actually took the Iceberg SDK and are using it because it makes it easy for us to write the manifest and to update manifest and to understand the structures within the manifests. Right. So so the Iceberg itself is a standard, right? If
Hmm.
Absolver implements the SDK, then Absolver is the compute engine.
Hmm.
Snowflake implements the SDK and knows how to read and write Iceberg tables. They are the compute engine that the user get to choose. Right now, the user can choose multiple compute engines. You can have one engine, let's say Absolver, who writes Iceberg tables, continuously writes them, updates them, inserts new data into them. And then they can choose a completely different engine, let's say Amazon Athena, Trino, Presto, Snowflake, DuckDB, whatever, to be able to query the data, right? To access that data. So there's going to be different engines. The same thing applies to Delta Lake. So it's exactly the same in that sense. Now, the difference is that Databricks as a platform chose to make Delta the default format for everything that users do, right? So if you're in a in a Databricks platform and you say create table, or you want to write some Spark, some Kafka data into a table, by default it chooses Delta, right? And
Hmm.
that's okay. That's just a product choice that they made. But the compute aspect of it is very similar, right? These both are table formats that using the SDKs and libraries, you can run them on any compute that you want. And that's really powerful because I can do it on my machine. I can
Hmm.
write an AWS Lambda function that can read and write, Iceberg and Delta tables. I can use polars, pandas, DuckDB, right? That's the beauty is that, all these tools are just picking up the libraries and starting to support these formats. So now as a user, you don't need to use just Spark, right? Or just Hive. You can really use anything. And that's what's really powerful about these open table formats.
Yeah. So what we are saying here is Snowflake, when Snow tables talk to Iceberg, they can do insert, update, delete, but as of now, Databricks cannot do. Correct? That's what we
So
are saying, right?
yeah, so I think that's a slightly different topic here. So from a table format perspective, anybody can implement it.
Yeah.
From a actual support perspective, what do you support and what functions of it do you support? That's
Mm.
kind of scattered across, right? There's different variables.
Mm-mm.
So Snowflake, for example, have two types of iceberg tables. They have an external iceberg table,
Mm.
which means that the iceberg table sits on an object store and cataloged on some other external catalog, right? So from within Snowflake, you create a catalog federation, right? They call it catalog integration. And then you connect to that external catalog. Those tables, Snowflake can only query them, can only read them. It cannot write into them.
External, yeah, correct.
Yeah. And then there's an internal one, right? They call it Snowflake-managed Iceberg tables. And those are just
Manage
like
Iceberg.
regular, yeah, those are
Uh,
just like regular native tables that Snowflake has,
mm,
but the data is stored in Parquet and in Iceberg with the catalog inside of Snowflake, right? In
ah,
those tables, you can do DML, right? You can insert,
mm,
update, delete, do all the stuff that you're used to doing with tables.
yeah, yeah. I got.
Databricks,
Mm.
yeah, sorry, go ahead.
So just to cover that piece, right? So correct, you correctly mentioned that so what we are saying is in Snowflake they have two types of managed tables. One is snow tables, second is iceberg tables. And we all know that yes, once you start creating external tables, external table is only read only. So
Yeah.
in Snowflake they have two types of managed tables, but in Databricks they have only one managed table, which is delta tables, and they have an external table on the iceberg where they cannot do the DML kind of stuff.
As far as I know, using Databricks. So Databricks is a lot of pieces, right? So from a standard Spark perspective, like if you just run a Databricks cluster with Spark, you
Hmm.
can connect to an external catalog like Glue or
Hmm.
Polaris or whatever. You just load the libraries, you
Hmm.
configure it. From that standpoint, you can actually read and write Iceberg just like you normally do.
Okay.
However, when you're running inside of the Databricks environment, if you want their catalog to work, if you want their notebooks to work, if you want their SQL engines to work, if you want the
Yeah.
serverless piece to work, you need to go through Unity Catalog.
Yes.
And when you go through Unity Catalog, currently it doesn't support Iceberg tables, like standard Iceberg tables,
It
right?
doesn't
It only
support as a
supports
managed iceberg table is not correct.
It doesn't support Iceberg at all. The only thing
Ah.
it supports is if you convert a Delta table into an Iceberg table, right? But
Mm-mm.
you yourself cannot register an Iceberg table, right? You
Okay.
have to create a Delta table, then you got to use Uniform to convert it to an Iceberg. Uniform will register the table in a Unity catalog. But
Uh,
you as a user, if you want to say register a table in S3, like you can't, right? They don't
okay.
have a mechanism to do that today.
Okay.
Now, I'm sure that will be added in the future, but today that's not the way it works.
Okay. Before we go further into it, I want to take this opportunity to discuss Hudi as well. So
Sure.
tell us about Hudi little bit, how Hudi sits. Are we saying the same discussion we are talking about iceberg versus delta and snow? Hudi plays the same part, another file system, or it has some other capabilities?
So I mean, Hudi just released actually version 1.0, so a new release for them. Hudi at a super high level, it solves the same problem, right? 30,000 foot view. It's an open table format. It's great for updating and deleting asset transactions, time travels, blah, 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 all those things that Iceberg and Delta give you. Where Hudi is different, or I would say more better suited for, is more of the near real time streaming, high volume type of workloads because it's much better for streaming data, right? The structure, the way that it stores information about updates and deletes is more efficient than Iceberg and Delta, so it's better for fast changes. There's a bunch more indexes. So when it comes to performance of writing and reading, there's more built-in sort of optimizations and accelerations to find the data quickly, resolve the merging of the data, deletes and the updates, and return the data back to the user. So you see them using a lot more file indexes. They implement a lot of Bloom filters. There's a bunch of things like that that just makes it more like a faster format for near real-time updates to data. Now, from an adoption perspective, initially it saw a bigger adoption with customers that have streaming sources, Kafka Kinesis, loading data into the lake through Hudi. But I think over the last couple of years, it sort of start to lose some traction because honestly, there's four different file formats or
I
sorry,
was about to
table
come there.
formats in the
Yeah,
market right
yeah,
now.
yeah, yeah.
Yeah. So, people are starting to kind of settle there's a big gravity on Delta Lake. There's a much bigger growing gravity of data around Iceberg. So do I really need Hudi? Like, I think it's great for a subset of use cases, but probably for like the 90% use cases that customers are building lake houses for today, Iceberg and Delta is a much better choice, and simply is a bigger ecosystem, a lot more support from vendors, much bigger community contributing into it. So ultimately, people want to put their data in a format that they know all their friends and family are doing, right? And everybody else is doing. You don't want to
Yeah,
be an outlier.
yeah.
But Hoodie is still being used, for streaming use cases. Obviously, Uber is a big user of it. But over time, I think it's going to start seeing less and less adoption as Iceberg and Delta become more streaming aware and improve those capabilities. And that's a big part of Iceberg 3.0 is more support for streaming and making sure that deletes are much more efficient for high volume.
So just to put few more angles on Hudi, right? When we say it's more for streaming, so I immediately come up the same question that if you write into Hudi, then how the third party or consuming party will read from Hudi and Iceberg or Hudi and Delta. So there'll be a confusion, right? That you have to
So
compute it. Yeah.
yeah, yeah. So to be honest, it's kind of like saying, I want to be able to read CSV files, JSON files, and XML files. I don't know how to do that. I'm confused, right? Uh, you're not, right? You know how to read a CSV, you know how to read a JSON file. They're okay, they're different, but from a query engine, from a tool perspective, it just supports them both, right? And
Hmm.
I think ultimately, we love to talk about format wars and who's going to win and who's better and who's that. At the end of the day, I don't think it matters. Right?
Yeah.
If you look at across the board, so like the AWS ecosystem supports Delta, Hudi, and Iceberg in a complete way. Databricks is kind of like an outlier here. Snowflake supports Iceberg in a complete way and starting to support Delta in a more complete way. The open source ecosystem, Spark, Trino, Presto, Flink, etc. They support all three formats. So I think if you give it like another year, maybe 2 years, there'll just be support for all of them. And from a user perspective, they're not going to know, right? If you,
Okay.
as a data engineer, ingesting Kafka data into the lake and you chose Hudi because it's more efficient for high volume, low latency ingestion, that's fine. Just write it into Hudi. The user doesn't need to know. Just user does select star from table and the catalog figures it out for them,
Yeah, because see
right?
what as an essay solution architect, what I can do is if I create an use case on top of it, I can process real-time streaming on Hudi, and then for historical, maybe I can throw a piece into Iceberg or Delta tables, right?
Yeah,
For
yeah.
other kind of analytics. Okay,
Or,
now
or just leave it in Hudi, right? I mean, Hudi is great
yeah,
at solving that problem too, right? It just, at the end of the day is, what you prefer, where do you prefer to put your data? Um,
yeah.
I think at the end of the day, it's all in Parquet files. As
So Hudi is
you
also
merge and
creates Parquet,
compact
is it?
stuff,
Yeah.
yeah, yeah, yeah,
So Hudi also has
yeah.
a Parquet at backend, is it?
That's right.
Okay,
That's
so
right.
now we are talking about Hudi, Iceberg, Delta, and Snow, which is Snowflake, right? We are
Yeah.
covering all four. So does Snowflake has
I mean,
these
we can add Redshift if you want to complicate it a little bit more.
Redshift we can bring, but we normally we treat Redshift as a RDBMS system, right? We can bring it in if you want to
No,
talk
I,
about
I
it.
honestly I wouldn't. I think over the last couple years, like they changed. I mean, it's not the Redshift of days
Yeah, yeah.
past, right? It's a different beast. So when you talk about Snowflake format, right? Redshift has something called Redshift Managed Storage (RMS), which is really powerful format that is very performant, works very similar to the Snowflake proprietary format, and they got support for Iceberg just like Snowflake does. So
Now
we should we
then,
shouldn't we shouldn't
again,
discount them completely, but it's
so
a lot of moving
then
parts here.
So then we have to bring Synapse into it. Then we have to bring Oracle as well into it. And if
No,
not
no,
to
no. We don't need
forget,
to bring Oracle into this.
no, and not to forget about Teradata. Actually, they are all now supporting Perky and all those kind of. The other day, I was sitting with someone on Teradata, and they have done some amazing stuff. But the thing is, when
Yeah.
Teradata, Oracle, and Redshift come into our mind, this old RDBMS concept come into mind, right?
Yeah, yeah. I don't know if I put Redshift in the same bucket as Teradata and Oracle. I think I would put them in the same bucket as Snowflake. But
Okay.
I agree that it's, if we're talking about data warehouses, we should include them all. I don't have much visibility into Oracle and Teradata, to be honest with you.
Yeah, yeah.
Um, but I'm not aware of any open table format work that these guys have been doing, but they could have been.
Yeah. So now, so when we talk about this four things, so just like Snowflake is supporting Iceberg, is it same kind of supporting Hudi as well or not as of now?
Snowflake does not support Hudi today. No.
I think same goes for Databricks. Databricks is also not
Yeah,
supporting
that's
Hudi.
correct. That's
So
correct.
Hudi
I mean,
is
you can use Databricks with just plain old
Spark.
Spark.
Yeah, yeah,
Yeah,
yeah.
but the
Yeah.
ecosystem of the Databricks itself does not support Hudi, as far as I know.
Yeah. So Hudi is playing in silo as of now, we can say.
Yeah, unfortunately. Yeah.
Unfortunately. Okay,
It's
now
it's a
let
very good technology. Hats off to them. They really built really, really good technology. My personal perspective on that is it came out and it was really hard to use. It was a very engineering sort of centered user experience, a lot of configuration, a lot of things to know, a lot of things to tune and tweak. And it was a little bit harder to use. It was harder to debug. They've made a lot of improvements since. It's significantly better. But I think that kind of difficulty of using and the simplicity of Iceberg and Delta, and then ultimately the adoption of more ecosystem tools using this and the big players kind of pushed Hudi to the side a little bit. But again, I don't think they're going to go away anytime soon. There's value to using it, and there's plenty of people who are still using them.
Yeah, just to close the loop of Redshift, and we just discussed Synapse, right? Correct me if I'm wrong, which I
So
think.
there's no more Synapse. So just so you know, it's Azure Fabric now.
Yeah,
That
they keep changing
that
their names.
product is gone.
They
Yeah.
keep changing their names every 2 years,
No,
right?
no, no. So Synapse is so the original Synapse is gone. They
Yeah,
completely
yeah,
shut it down, and
yeah,
they
yeah.
rebuilt it. They rebuilt
As a fabric.
Synapse as part of Fabric. Yeah, it's a completely rebuilt from the ground up.
Yeah. So why I was not keeping Redshift and this thing Synapse, because they are very much Redshift is only on AWS, Synapse is only on Azure. They are not
That's
crossed.
right.
And these
That's
other
right.
four file system which we are talking about, Hudi, Iceberg, Delta, and Snow, they can be cross clouds. That's what
So
I'm
so
trying to.
let's not confuse that. So Snowflake as an engine can run on any cloud. Redshift
Yes.
does only run on AWS.
Yes.
However, Iceberg Delta Hudi can run on any cloud.
Yes.
Right? That's
Yeah.
that's not tied. That's not so much tied. Like if I
Yeah.
write Iceberg table in Redshift and then I read it in Snowflake, or I copy it over to Google and I read it from Big Lake or BigQuery, I can do that too.
Yeah, but as a product itself, these are cloud agnostic product. But Redshift and Synapse are not cloud agnostic.
Yeah, you're
Although
right.
they can run into IES, but let's not go there. But
No, no, no.
natively
Yeah,
they
yeah.
run
I'm
in
with
their
you.
own. Yeah.
Yeah.
Okay. Now let's go towards little bit more towards detailing of Iceberg, right?
Mhm.
We have 20 odd minutes. So so when we talk about optimizations, right, we know Snowflake, when you write down into Snowflake managed tables, they do a lot
Mhm.
of optimization over there, mini partitioning, blah blah blah, XYZ. You go into Delta, Delta is not there as of now. It doesn't do a lot of things. You have to do it by yourself. What about Iceberg? Are we saying Iceberg can comes out of box, or it's also manual driven?
So Iceberg is very similar to Delta,
Okay.
in the sense that it gives you. knobs and levers and ways to do things, but it itself doesn't do anything because it's a table
Okay.
format,
Okay.
right? So like you would, both Delta and Iceberg will give you ability to compact data, right? Merging small files into bigger files with some properties to say only merge these files, only merge when they hit a certain threshold, right? So you get some flexibility, but again, it's a standard. It's like, here is how you should be doing it. But
Hmm.
then the engine itself has to implement that. So if you want to do it, Spark has to do it. Databricks did a bunch of work to automate a lot of these things. Initially, when Delta came out, you actually had to type the command optimize, right? Optimize
Hmm.
table. And then it will do a bunch of work to optimize it. Now it's automated, right? Like I'll give you an example, like in Absolver, for example, we invest a ton of time in automating and making this whole process adaptive and intelligent. So there are hooks to say, this is how you compact data. This is how you clean up snapshots. This is how you delete files. We are doing that, but we're doing it in a more intelligent way. So we're collecting information about the data so that you don't have to tell me, oh, compact the data when it hits this size, or every 10 minutes compact it. That's not really relevant to you. Like, it's not something that you want to worry about. We will look at the data. So if, for example, we're ingesting from a real-time source, like a database stream, and we're getting lots of updates and deletes per minute, right? Lots of them. That means we're going to need to compact the data much more frequently. But if we're reading from an S3 source and we're getting new files every hour, there's no need for me to compact the data every
Hmm.
minute, right? It's a waste, right? In a standard Iceberg or even Delta, you'd have to configure the table and say compact when the data reaches a certain threshold or every X number of minutes. Like, you'd have to orchestrate it, right? You have to do that work. The engines that implement the file format or the table formats are the ones responsible for providing automation, right? For providing intelligence. So Databricks does that really well for Delta. I'd say Absolver does it really well for Iceberg, but there's also tools like Snowflake, for example, has their own optimizations for Iceberg. Today, it's very basic, right? There's not a lot of intelligence in it. But think about it. In the future, they'll say, okay, let's take all the intelligence that we built for the Snowflake native format and apply those things to Iceberg, right? There's some work to be done there, but they have the knowledge, they have the expertise, they have the abilities to do that. So I actually wrote a blog post about this where I think the kind of like the next competition, right? The next thing we're gonna be competing on is managed table formats and optimizers. Who has the best lake optimizer? Right?
Yeah.
Databricks is investing a lot of time. Absolver is investing a ton of time and effort into this. I think Snowflake will get into it. AWS has two optimizers now. They have one inside of Lake Formation, and now with this new S3 tables thing that they released, there's one built in that as well. Right. So I think the next race is going to be who has the best optimizer, but ultimately it comes down to the engine that is writing the data is the one responsible for optimizing it as well.
Yeah. So now let's come towards cataloging, right? Snowflake has their own catalog, Databricks has their own catalog,
Okay.
where this Iceberg catalog is, because this access matrix, privacy, all goes into catalog. How
Yeah, yeah.
and which tools support Iceberg, and let's bring Hudi as well into it. Yeah.
Yeah, so that's a really good and interesting topic. I'm actually working on a blog post that talks into more detail about that. Um, so from a catalog perspective, right? Let's leave to the side business catalogs, right?
Mm.
That kind of
Yeah.
stuff. Let's just leave that aside for now.
Yeah. Talk
We're
about
talking
technical
about
then.
technical
Yes.
catalogs, also known as meta stores,
Yeah.
right? There's traditionally a Hive meta store. Databricks knows how to work with a Hive meta store. Snowflake knows how to talk to an external Hive meta store for external tables. Each of these engines, right? Let's use Snowflake and Databricks for a second. Snowflake has its own internal catalog, right? As any warehouse would. Databricks has something called Unity Catalog. That's a
Yeah.
catalog that they built for their platform.
Yeah.
Now, in July, I think it was June,
They
July,
already
they
open
open
source.
sourced it.
Yes.
Yes, they open sourced it. Around the same time, Snowflake also came out and say, hey, we're going to open source a catalog as well. The main difference is that Snowflake open source Polaris catalog, and it's written based on a specification that was defined by the Iceberg community. And what the Iceberg community said is, hey, we don't want to go to every engine and tell them, hey, please build integration into Iceberg, and we have a special catalog. Here's how you connect to us, right? So what they said was like, let's just create a standard. We're going to create a standard that anybody can implement, and it's using standard REST API. So if you know how to build a web server, you know how to build this. Here's a set of REST APIs that we're going to expose. And then any engine that wants to interact with Iceberg tables will be able to use this catalog specification, right? And that's called the Iceberg REST catalog, right? That's what people kind of refer to that. And what that means is now any catalog, Unity, Glue Data Catalog, Polaris Catalog, you name it, right? If they implement an Iceberg REST endpoint, all the engines that know how to read and write Iceberg using the SDK can just plug into it and they don't have to do anything else, right? There's no extra work to be done, right? So that's really powerful way of sort of standardizing the dialect, how to speak to a catalog, but also modernizing the catalog. Like we could have easily used Hive, right? Tell everybody, hey, go implement Thrift or JDBC, but then how do you do that with Polars and Pandas and DuckDB and like these guys don't want to touch Thrift and JDBC, right? Now that we have this REST catalog, almost anybody can integrate with it. It's super easy. It's just like any web server, right? So that makes cataloging lightweight, modern, and easy for any tool to just plug into it without a lot of effort, right? Now, that's why the Iceberg REST specification is exciting. Now, from a vendor perspective, you have Unity Catalog, who came out of Databricks, and all the Databricks users are using it because that's the only catalog they got in Databricks. They open source it, so now it's a popular catalog for people to use. However, it has a very small part of an Iceberg REST implementation, right? It's a read-only
Read
implementation.
only, yeah.
Yeah, which is a problem, but they have it on the roadmap sometime later next year to be complete. Polaris catalog came out from Snowflake. So Snowflake has an open source version called Apache Polaris catalog. And they have their own version of Polaris fully managed. I think it's called Open Catalog for Snowflake. It's basically Polaris managed by Snowflake, right? And you don't need to be a Snowflake warehouse customer to use the managed catalog. You can just simply be a catalog user, right? And it works the same way as Polaris. It's just managed by Snowflake. On top of that, they added RBAC, like resource-based access control. So Polaris has RBAC similar to what you get in Snowflake, similar language, similar capabilities. Databricks with Unity Catalog have very similar RBAC capabilities as well. At reInvent, AWS announced Iceberg REST support for Glue Data Catalog. And then on top of that, you have AWS Lake Formation, which gives you RBAC. It gives you TBAC, which is tag-based access control. So a little bit more granularity and flexibility. So I'd say those are the three kind of main competitors in the market. And then there's others who are coming up, like Lakekeeper is an open source one that's coming up. That's really cool. And a few others that are starting to kind of pop up.
Yeah, actually, this catalog piece is very is very key for managing all this RBAC, right? I give you an example of Databricks Unity Catalog. The
Right.
major conflict I have with Databricks is they have a flat catalog concept, right? They don't have a hierarchy of catalogs. That
Yeah.
if you have one LOB, within that LOB, there are many departments. So catalog hierarchies are not there. I'm not sure about Snowflake. I'm not sure about others, but Databricks don't have. So do you
Yeah.
see anybody coming up with this hierarchy? It's not possible. How do you see that?
Yeah, so the Iceberg catalog specification defines the concept of a namespace. And a
Hmm?
namespace is a catalog. There's a catalog and there's a table. Between them, there are namespaces. So you can have as many namespaces as you want, right?
Okay.
So I think that can help kind of your use case to say, have a namespace for each LOB. Under each namespace, LOB namespace, you have a database namespace or multiple database namespaces and then tables, right? So the Iceberg spec provide for that. Polaris does support some namespace nesting.
Mm,
Glue Catalog, I think, only has one namespace nesting, like catalog databases tables. They potentially will have others. Dremio open sourced a catalog called Nessie that has more dynamic kind of namespaces, so you can create multiple namespaces. So the concept is there, right? It's in the spec. It kind of comes down to whether the catalog vendor decides to implement it or not.
mm,
Many times it's just because of how they build their data model to store that information. If they,
mm.
have a, restricted data model like Unity Catalog does, then they try to fit into like the database model where you have schema, database, table, and that's it.
Yeah.
The Iceberg spec, right? The Iceberg specification has a
Mm.
table spec and a catalog spec,
Ah,
right? The
okay.
table spec is what we've been talking about till now. The catalog spec says this is a modern way of talking to catalogs, right? And
Okay.
here's a set of REST APIs that any engine can implement. It's modern, it's
Got
standard,
it.
anybody can use it, right? And Polaris Catalog is based on that standard.
Because where I'm coming from is, for me, there's always dev, UAT, and production, three environments, right? And
Yeah,
at a network level, there are separate network zones. The challenge I face is database Unity catalog sits at an account level.
yeah,
Not they can You cannot have multiple hierarchies. So you have an account level catalog, and all dev, UAT, in production all sits into one catalog. That's a
yeah,
problem
yeah,
for me, but that's how it is. They are saying.
yeah.
So
So like Polaris Catalog, for example, will let you create. So Polaris Catalog, like the physical compute, right,
Mm.
will be like a machine running, a server running in the cloud, wherever. So that can be in like, let's say one region, but inside that in the catalog, you can subdivide it and say I have catalog one, catalog two, catalog three. Under each of those three catalogs, you can then have additional namespaces. Database one,
Yeah.
database two, database three. Under each of these databases, you have tables, right? So you have more flexibility in this hierarchy that you're talking about. And at each of those levels, you can define resource-based access control to say, Roy has full control of catalog three, but Mustafa has full control over catalog one, but both of them only have read access to catalog two, right? Or a subset of databases or tables within these catalogs.
Yeah.
And that model is available in a Polaris catalog. Nessie catalog has it as well. Like you said, Unity is a little bit more limited in that sense. But I think you're going to see more and more vendors coming out trying to kind of bring more modern catalog governance, security to the open lakehouse.
Yeah, because you need a catalog who might be supporting every all file formats. There's
Yep,
the ideal way of doing
that's
it,
right.
right? Now coming towards this is a challenge which I feel everybody has it. As an SA, I also have it. And in my own DAS architecture, my aim is to segregate compute layer with the storage layer,
Mhm.
right? And when we talk about file formats, normally in our back end of our head is file format. When we talk about, we say only Perk, JSON, these are file formats. We
Yeah.
don't treat Iceberg, Delta, and all those things as a file format. So when we write into Iceberg, right? For example, I am dependent. Well, now this is a question from not from a technical perspective, but from a risk perspective. If I'm
Mhm.
dependent on Iceberg, I am tightly bundled with Iceberg, right? Tomorrow, if I go to XYZ, I have to do the complete migration. How do you see that piece? Is equal to you are on Oracle, tomorrow you have to go to Teradata or XYZ, vice versa. You have to do the complete migration. Here we have to do the same thing, right?
So we should be careful to sort of separate things. So when you talk about like Oracle migrations, there's data migration and there's kind of workload migration, your SQLs,
Yeah, yeah, yeah,
your
yeah.
store procedures, that kind of stuff.
I'm talking
But
about
we're
data.
talking
Yeah.
specifically about the data.
Yes.
So when we say migrate from Iceberg, it's migrate from Iceberg to Delta or migrate from Iceberg on AWS to migrate to Iceberg on Azure, for example. If it's Iceberg to Iceberg, just different environments, it's very easy. The only
Easy.
thing you need to do is re-register that table in a different catalog,
Yep.
right? Which is a metadata only operation. It's very simple to do. When
Hmm.
you're talking about moving from Iceberg to Delta, for example,
Yep.
or from
Yep.
Delta to Iceberg, the data files themselves are, I would say, not quite consistent. The way that Iceberg writes Parquet files requires some additional bits of data in there that Delta doesn't understand, like field IDs. And that's how Iceberg deals with schema evolutions.
Hmm.
Delta doesn't require field IDs. So the
Hmm.
data, even though it's stored in Parquet and it's open and available, they're not quite compatible,
Yeah.
right? So like going from one to the other is there's a little bit of friction there. Now you can go from Iceberg to Delta without a problem and then not lose schema evolution. Going from Delta to Iceberg, you may lose schema evolution, right? Because Delta doesn't know how to rewrite it in this. From a metadata perspective, again, it's I would call it like a light lock-in because it's open source, it's available, it's readable, and nothing is in proprietary formats. So if you wanted to go from Delta to Iceberg or Iceberg to Delta, you can either so Iceberg has the mechanism of re-registering data. So let's say you have Delta Parquet files, you bring them over to an Iceberg table and you say add file, right? And it simply adds the file into the manifest for you, right? If you go from Iceberg to Delta, they don't quite have that mechanism, so it's a little bit more extra work. Now, in the community, there is a project called Apache XTable, and Apache XTable is an engine that converts between these table formats. It doesn't convert the files, the data files themselves, but it does convert the metadata files, the transactions, right? And the
Hmm.
manifests. So using XTable, you can easily say, take an Iceberg table, make it a Delta table. And it will just take the manifest files, convert them into the Delta transaction log, and then you have a Delta table,
So we are
right?
saying, okay, let me little bit emphasize on it. You're saying Apache XTable. What is
Correct.
this? Never heard about it. Is
Yeah.
it a new
So it's
thing?
actually it came out of the Hudi guys. So
Okay.
Vinod and team from Hudi from One House came up with this Apache XTable, and it's basically open table format converter, right? It goes
Converter.
from one format to the other. Under the hood, actually, Fabric, Azure Fabric, they write into Delta, and then they use XTable to convert it into Iceberg, right?
Oh,
So
so
that's how Azure Fabric supports Iceberg today. So you can actually run it. It's a utility. You just run it on your machine or whatever,
hmm.
convert one format to the other. So
so so
portability
hmm.
is pretty simple.
So what you're saying is in this way, using this Apache X table feature or a tool, you don't have to rewrite the data. Data will still remain at same, only
That's right.
metadata you convert. So I think this will be true for all other file formats coming into picture
Table
in
formats.
future, table formats
Table
in
format.
future. So I think this can be a take. I will note down this X table thingy
Yeah,
because
check it
what
out.
I want is I want my storage layer to be totally decoupled with the compute. Now within compute and storage, this file format come into picture.
That's right.
Storage,
That's right.
file format, and compute. So it's actually it's a good takeaway for me for my last architecture. So
Yep.
so what you're saying is who knows tomorrow. So you're saying that Iceberg matter to delta this X table works. Does it also work with Snowflake and Hudi and all those other file
So
table?
when you say Snowflake, it doesn't work with Snowflake proprietary format, but it
Okay.
would work with so it works with Iceberg, Hudi, and Delta right now.
Okay. X tables. Yeah.
Yeah, and those are the primary formats. It doesn't convert proprietary formats, just these three open table formats, right?
Proprietary.
So let's say for example, you're a Snowflake user, and all
Hmm.
you do is Snowflake. And then
Hmm.
tomorrow you get acquired by another company, and the company says, "Hey, we don't use Snowflake. We're a Databricks shop.
Hmm.
We're gonna need to move all of our Iceberg tables that you created in Snowflake to Delta. Just the way we're gonna do things, right?" So you can bring in X tables and you can say, okay, go look at all these tables that I created in Iceberg, convert them all to Delta, and then off you go, right? And that's kind of your portability, your compatibility story, if that kind of happens. Now it doesn't happen often to a lot of people, but it's there as a backup plan, like if you need to make that
Mhm.
conversion.
So you are saying this is there for Delta, not for Snowflake as of now.
Not for Snowflake proprietary format, correct?
Okay.
Only Iceberg, Delta, and Hudi. It only converts between those two formats.
Okay.
Because nobody understands the Snowflake proprietary format. only
No,
only Snowflake does.
but who knows that XTable will come up with that as well in future.
That's only if Snowflake opens up that format and gives it to them, right? I don't think they will. I don't think they will. But they may, the other option you can do is you can take a Snowflake proprietary table, export it into Iceberg, and then from there convert it, right?
Yeah, but that will be a complete migration itself.
It is. It is. There's limits. There's limits to
Yeah.
everything.
Okay,
Yeah.
I think we have a time check of 3 minutes. So, Roy, it was a great session with you. And it's pleasure again because we started with the iceberg, but we end up doing a comparison of Hudi, iceberg,
Right.
Databricks, or Delta tables and Snow tables as well. So we have covered all those four. And thanks for bringing this X tables as well into the picture. So we talked fifth topic as well.
Yeah,
So
that's right.
yeah. So again, thank you so much. I think this is our first session. It should not be our last session. I would love to have
Absolutely.
more
It will be
sessions
my
with you.
pleasure.
Yeah. Again, thank you so much. Have a nice rest of the day and see you again.
Thank you so much, Mustafa. It was a pleasure.
Take care. Take care.
Take
Bye bye.
care. Bye bye.